Okay, so now we're going to put it all together. So this point right here, that is called my relative maximum. Okay, this point that's down here, that is going to be my relative minimum. Really? Minimum. Whew. Then, the next part. This part right here, that part is decreasing. It's going down from left to right. Remember, we're going from left to right. This part is increasing. Okay? Remember, we're going left to right. That part is increasing. Okay. So, in 2015, Christoph Strausser set a new 24-hour cycling record by riding 556 miles in 24-hour period. The distance he rode over the 24 hours can be represented by a function. Sketch the graph that shows the distance traveled. Okay, so here we're going to go, and it says y-intercept, no distance traveled when he's ridden 0 hours. So I'm going to come down here, and I'm going to plot a point right there because he hasn't ridden anything yet. Okay, then it says linear and nonlinear. This is linear, so I'm going to have a line. So it's going to go like so. Positive. Okay, so anytime the time is greater, so we know it's going up, increasing, okay? As he's ridden increases, the number of miles increases. So we know it's going to go up. So in 24 hours, we know he's gone 556 miles. 24 hours, 556 miles. So, voila. Okay. Next one. A person's happiness can be affected by temperature. Sketch a nonlinear graph that shows the happiness of a person, y, as a function of temperature x. Interpret the key function. Okay. So it says between 25 degrees Fahrenheit and 89 degrees Fahrenheit. So between 25, so between here and here, those are going up by tens. So here, somewhere in here, all of it is above there, okay? Negative, the temperature is less than 25 degrees. So all of this down here, so this part down here goes from this mark to this mark. So that part's down there. Increasing for the temperature is 57 degrees Fahrenheit. So it's going to be increasing for for temperatures less than 57 degrees. So 57, I'm going to do this, 57 degrees. So we're going to say this part is increasing. So we know it's increasing here. Decreasing for numbers greater than 57. So this side is going to be going down. Then it says relative maximum is about 57 degrees Fahrenheit when a person happiness 85. So 57, 85. So I'm going to put 57, 85. So this is the point, 57, 85. So this is my relative maximum. Okay. In behavior, as the temperature increases or decreases, person happiness. Okay. So basically, what we're doing, this is going to be not so fantastic. Ooh, that was horrible. Okay. Something like that. Okay? Is it perfect? No, but that's approximately what it's going to look like. Okay, so here, Mariani uses key features to sketch the graph. Positive between x is -3 and x is 0. X is -3, 1, 2, 3, to 0. Is it positive up there? It sure is. We're going to hit correct for that one. Then the next one says negative for less than -3 and then between 0 and 2. So less than -3 and between 0 and 2. Is that negative? Yes, it is. Then increasing means it's going to be increasing for x is less than -2. Oh, am I using? No, I want to use a different color. X is -2 from right here. X is -2. Less than that is increasing, and between 1 and 3 it's increasing between 1 and 3. So between 1, 2, 3, it's increasing. Now if it had said x is greater than 1, I would say yes. But because this has an arrow going up, that's going to go on forever and ever. So that is incorrect. Okay, so the next one, decreasing. So we're going to be decreasing between -2 and 1. So -2 and 1, we're decreasing. And then for x is greater than 3. There's no other place it's decreasing. So that's incorrect. Ugh, silly thing. Okay, so do green this time. The intercepts, the graph intersects the x-axis at -3, 0, 1, 2, 3. That one's right. 0, 0, and 2, 0. Yes, that is correct. The relative minimum is 1, -2. 1, -2. That is correct. The relative maximum is -2, 4. -2, 4. So 1, 2, 3, 4. That one's right. And there's no other relative maximum. So no. As x increases and decreases, as x increases, the y's are getting bigger. So this statement is incorrect. Okay. So this is going to be positive between x is negative 0.5 to 12. That part's going to be positive. Okay, negative out here, negative, and then okay, so this is below the graph. Okay, increasing. So it's going to be increasing when x is less than 1.4. 1.4, so it's going to come up to here. And then between 5.3 and 9.9. 5.3 and 9.9. Those places is going to be increasing. It's going to decrease between 1.4 and 5. Okay, so it's supposed to decrease somehow here. And then when x is greater, so it's supposed to come down like that. Okay? The intercepts. Okay, so intercept is negative, so it's right here. And 12, it's right here. The y-intercept is 0 to 20. Right here. Okay. Then we have a relative minimum at 5.3, 133. Yeah, I'm just trying to figure out points to use. 5.3, 133. 5.3, 133. And then we have a relative maximum at 1.4, 488. And then at 9.9, 643. 9.9, 643. Okay, so it's just going to go up, down, up, down. So I can get rid of these guidelines. Get rid of these guidelines. We're going to draw our graph. Now, is that perfect? No. Oh, that's horrible to me, but looks like that. Okay, as x increases or decreases, the y decreases. So that is what your graph should look like. Okay, so it says, marine line. The path of the dolphin jumping out of the ocean can be modeled with symmetric function. It's positive, so it means it's above the water from 0 to 8 seconds. Okay, is this above ground 0 to 8 seconds? It is. Is this above ground from 0 to 8 seconds? No, so it's not it. Okay, is this above ground from 0 to 8 seconds? Well, sort of, yes. Is this above ground? Yes. Then it says for the times less than 0 and greater than 8, it's negative. Well, this keeps going higher and higher. This keeps going higher and higher. So that can't be it. So A has to be it. Negative values represent below water, and before the time starts. Okay. Oh, sorry, negative X value. I apologize. This is before, or sorry, below the water. I know, it helps if I look. Compare properties. Okay. Hawkeye is a computer system used in a tennis to track the path of a ball. It is used in an officiating aid to locate the landing spot of a tennis ball. When players challenge a call, use the description and graph of a player's forehand and backhand shots to compare the paths of the two shots. If Y is the vertical height and X is the distance. Okay, so let's do this. It says, during the forehand, the ball leaves the player's racket at a height of 2.8 feet. So it leaves his hand or her hand. So that would be the y-intercept. Because at 0 seconds, it is 2.8 feet in the air. And travels 29 feet. So when it gets back to the ground, it's at 29 feet. So that's 29, 0. Okay? When it reaches a height of 10 feet, oh, it helps if I read the whole thing, guys. I apologize. I'm having a really hard time on this one. During the forehand, the ball leaves the player's racket at 2.8 feet, not 28 feet, and travels 29 feet when it reaches a height of 10 feet. Okay, so let's try this again. The y-intercept is 2.8, not 28, but 2.8. Then the height of the ball decreases and hits the ground at 58 feet. Okay? The extrema. There is a maximum height. And the maximum height for that is going to be 29 feet at 10 feet high. Okay? So it is increasing. It's increasing, so it's getting up and coming back down. This is the middle. So the X value from when the X is 0, when the X is 0 to when the X gets to 29 feet, it is increasing. It is decreasing from 29 feet until it hits the ground at 58 feet. Okay, so now let's look at the backhand. So where does it hit, or where is it at? oh, I want to say it's at, I don't know, 2.7. Okay, where does it hit? It hits right here at 70. So 70, 0. Okay. Then this is about here. So it's going to have a maximum height of, the point, I don't know, 32 and 7 feet. It's increasing from 0 till it gets to 32, and then it's decreasing from 32 until it hits the ground at 70.